Hello and good day everybody. Welcome again to Engineering Physics, and in this video we would now be discussing about vector addition. But before proceeding with vector addition, let us now have an example of scalar addition first. So adding scalar quantities is very straightforward. What you would be doing here is just that you would be adding them. So for example, that you would be having a scalar quantity in mass of, let's say, 5 kilograms. And let's say that M2 is now to be equal to 1 kilogram. So M1 plus M2 is equal to, so 5 kilograms plus 2 kilograms. So easy peasy lemon squeezy. So 7 kilograms. And take note guys that if you would be adding two quantities, you must first convert them for them to have the same units. So for example, that instead of 5 kilograms and 1 kilogram, so let's say that this is now to be 5 kilograms and let's say 2,500 grams. So for example, that I want my answer to be in terms of grams, I would now be converting this first into grams. So with that, M1 is now to be equal to 5,000 grams. So M1 plus M2, so that is to be 5,000 plus 2,500. This is now to be equal to 7,500 grams. So basic. Okay, but in vector addition, guys, so as you can remember in our previous example, so these are to be one example of a collection of vectors. So let's say once again that in this example, so let's have an example here. So let's say that this is now to be vector number 1. And let's say that this is now to be vector number 2. So let's say that this is now to be vector number 2. So for your vector 1, so let's say that this is now to be equal to 7 meters. Let's say 30 degrees from the origin. And for your V2, so let's say that this is now to be 12. Oops, sorry. Let's say that this is now to be 4 meters. And let's say its direction is now to be equal to 25 degrees north of west. So this is just an example, guys. Okay, so adding them isn't as simple as adding them this way. So for the resultant or for their sum, for their summation, that is not equal to 4 meters plus 7 meters. So this is actually wrong. So you cannot just add their magnitudes. Okay, so before proceeding, guys, so when we are to add vectors, the result is what you would be calling our resultant. The combination of vectors is what we call the resultant. So, resultant. Okay, so there are plenty of ways on determining the resultant, or let's say there are plenty of ways in adding our vectors, and we have these methods here. So we have here your algebraic method, parallelogram method, triangle method, polygon method, and the component method. So as you can see, we have an emphasis on the component method, and that is because that I want you to focus on the component method because you would be making use of this method up until you graduate engineering. Okay, anyway, so let us go from method to method. So let us go here first. So for your algebraic method, so you can only make use of this method if your vectors are collinear. So for example, that let's say you have a vector A. So let's say that you have your vector A, and your vector A is to be equal to 7 newtons, then 30 degrees. And let's say that you have a second vector, and let's say that this is let's say 70 newtons, and it is also 30 degrees. And let's say that we would be having a third vector that is to be, let's say 10 newtons, 30 degrees, or let's say negative 10 newtons, 30 degrees. Okay, so if you would now be drawing these ones here, so let's say that this is now to be 7 newtons. So 7 newtons. Then we also have 17 newtons. And we also have negative 10 newtons. So as you can see, all of them have the same angle, so meaning that they are parallel. So if they are parallel, let us assume that they are all collinear. So with that, this is now to be equal to 10 newtons. But take note, guys, as for this direction here, this is now to be 30 degrees. So 30 degrees, so the line should be like this. However, its magnitude is now to be negative. So instead of putting the arrowhead here, you would now be placing them at the opposite side. Since once again, this is now to be 30 degrees, 30 degrees, and 30 degrees. Okay, so for your algebraic method, this is very, once again, very straightforward. What you will be doing is just that you will be adding them. So with that, if this is now once again to be 10 newtons, considering this direction, so for the resultant, so the resultant is to be equal to, so I will just be changing the color. So for the resultant R, this is now to be equal to, so I will be assuming that this direction would be positive. So I will be assuming that every vector going to this direction is now to be positive. Okay, so with that, this is now to be equal to 7 newtons. Then I will be adding this, so plus 17 newtons. And since this is to be directed oppositely, this is now to be negative 10 newtons. So with that, my resultant is now to be equal to, so the resultant now is to be equal to, looking at the calculator to your left, so 7 plus 17 minus 10. So that is now to be equal to 14 newtons. However, so what is now to be the angle? So if you can see, guys, that the resultant is now to be going to this direction. So this is now to be 30 degrees. So same pa rin siya ng angle. So it would be having the same angle because if you would be adding them, the resultant would still be along this line. Kasi wala naman nagbago. So with that, 30 degrees. So this is now to be your resultant using algebraic method. Okay, so next, parallelogram method. So this method is applicable if you only have two coplanar vectors. So it doesn't necessarily require you to have two collinear vectors as long as they are coplanar. Okay, so what we would be doing here is that, so for example, that you would be having a line here or a vector here. So let's say that this is to be your vector A. Then you would be adding it with vector B. So let's say that this is now to be vector B. So for parallelogram method, what you would be doing is that making use of these two vectors, you will now make an imaginary parallelogram. So what I mean here is that I will also draw a line here that is parallel to this vector here, and I will also draw a line here that is parallel to this particular vector here. Okay, so for the accuracy of my drawing, I will just be copying this. So this is now to be my imaginary side, as well as for this. So I will just be erasing a portion of it to indicate that this is just an imaginary line. So there. So we now have an imaginary parallelogram. Okay, so this is, this method is kind of a graphical method. So you can use trigonometry or graphical, but this method is mainly used for graphical method. So by graphical method, what you would be doing is that you will be drawing this in scale, drawing yan in scale, drawing nyo to in scale, drawing nyo to in scale, drawing nyo to in scale, and draw a line. So let's say that the resultant is to be this. So magdraw ka ng line from the origin up until the other vertex. So the other point here. So just draw this. And once that this one is drawn, already drawn, what you would be doing is that you would be measuring this line. And that is now to be your magnitude. So for example, that this is now to be equal to, let's say 8 newtons, for example. So for example, that this vector here is now to be equal to, let's say 25 newtons. And let's say that for this red one here, this is now to be equal to 20 newtons. Okay, so for example, that you have chosen a scale that for every 1 centimeter that you will be drawing, that represents 1 newton, for example. So if this is now to be your chosen scale, if you would now be drawing this on your paper, you would now be drawing this line 20 cm. So 20 centimeters. And once again, if this is now to be your chosen scale, you would now be drawing this line as 25 centimeters. So this one represents 20 newtons and this one represents 25 newtons. And once that you have drawn these imaginary edges here and you have drawn your parallelogram, so draw a line from this point to this point and measure them. So once that you have already measured them, so for example, that in this line, you have measured this as, let's say, 40 cm. So once again, for an example, so you have measured it at as 40 cm. It means that your resultant is equal to 40 cm. So just multiply it by your chosen scale. So once again, so times, so for every 1 centimeter, there is 1 newton. So with that, centimeter would cancel out. So your R is now to be equal to 40 newtons. And for its direction, draw an horizontal line here and get a protractor and measure this angle. So once that you have measured that angle, so include the angle here. So this is now to be your resultant, assuming that my answer here is correct. Okay, so guys, another thing that you should review is to be your scaling. So ganito. So you can choose any scale you want. So as you can see here, I have chosen that my scale for this line, or for this figure, is that there is to be 1 newton for every centimeter drawing that I have drawn. So for this to be representative in proper scaling, I have drawn 20 centimeters. So if you want it to be mathematically proven, so for your 20 newtons, if you want this to be the scale, so just multiply this by, so 1 newton, then 1 cm. So newton would cancel out. So this is now to be equal to 20 cm. So ayun. But what if, for example, so you have chosen a scale of 2 mm for every 0.6 newton. So for example, that this is to be your chosen scale, which is very unusual. So if you want to draw this line right here, so just write 20 newtons, then multiply it by your scale. So in this scale, guys, so since you want to cancel newtons here, so include 0.6 newtons here. And of course, you want to write in terms of millimeters. So with that, write 2 millimeters here. So this would now cancel out. And your answer here is now to be equal to, so looking at the calculator to your left, 20 times 2 divided by 0.6. So this is now to be equal to, so 66.6 millimeters. So with that, guys, if you have chosen this scale right here, then you will now be drawing 66.6 millimeters to represent 20 newtons. Okay, so side note, so since you have measured from this point up until this point, and the arrow is to be located here, so this is now to be your resultant. So once again, when you say resultant, this is to be the combination of vectors. However, guys, so for example, that in the question, what is being asked is to be your equilibrant. So equilibrant. If the question asks for the equilibrant, it is actually the opposite of the resultant. So if this is now to be your resultant and this is now to be your arrowhead, so for your equilibrant, your arrowhead should be at this point. So what is to be equilibrant? Equilibrant. So your equilibrant is to be a vector So I would just be writing here. So vector that when added to a combination of vectors will result to a resultant equal to 0. So what that means is that if, for example, that you have a certain vector, so let's say that this is to be your vector and this is to be your vector, if you would be adding another vector, the resultant, so the resultant of these three will be equal to 0. So similarly a while ago, so when we have solved for the resultant, so gumawa tayo ng line dyan, gumawa tayo ng line dito, then for the resultant, so this is now to be the resultant of both of the vectors, assuming of course that this is just an imaginary line. This is just an imaginary line. Napasobra. So imaginary line, imaginary line. Okay, so this is now to be your resultant. And for the resultant to be 0, kapag ang hinahanap equilibrant, baliktarin mo lang yung arrowhead. So ito na dapat. So ayan. So take note of course, the angles and the directions. Okay, so proceeding to the next method. So there is this thing which we call triangle method. So this method is a kind of similar to your rectangular method. It's just that this is kind of an analytical method. So you can only make use of your triangle method if you would be having two coplanar vectors. So more than that, you cannot use this any longer. So two coplanar vectors. Okay, so what you would be doing here is that, for example, that you have two vectors. So let's say that this is now to be your two vectors. So vector 1 and vector A. So for example, vector 1 and vector A. So what you would be doing is that you will be joining them from head to tail. Let's say that this is now to be your vector A. This is now to be your vector B. So instead of their tails connected, you must connect them from tail to head. You can either move this here, or you can also move this here. So it would be up to you. Because if you do it right, their answer would would still be the same. Okay, so with that, once that I will be moving this vector here, if I am to connect the end here to the head here, so from the tail up until the head, so if I am to connect that like this is now to be your resultant. So if that is to be the case, you can now make use of any trigonometric functions for you to get this R. So for example, that this one is to be 90 degrees. So this is just for an example. So this is now to be 90 degrees. So for you to get the value of R, you can make use of Pythagorean theorem. So from your Pythagorean theorem, your hypotenuse, so the square of your hypotenuse is equal to the square, the sum of the square of the two sides. So with that, so in this case, so R squared is equal to, so B squared plus A squared. So plus A squared. So assuming that you already know both of these values, you can now solve for R. So let's say that you already have, you already know the value for your R. So the next thing that, that you should solve for is to be the direction. So for the direction, so let's say that you would now be making use of this angle here first before solving for this particular angle. So solving for this particular angle is very basic. So you can actually get the arctangent. So theta is to be equal to arctangent of opposite divided by the adjacent. So A over B. So that is if, for example, that this is to be 90 degrees. So take note guys. So kung medyo nalilito kayo dito, please review trigonometry. So this is just a simple Sokotowa rule. So there, so simple Sokotowa rule. So if you are getting confused right now, please review your trigonometry. Okay, so once again, this is only applicable if this angle here is to be 90 degrees. However, so what if the angle that was formed there isn't 90 degrees? So once again, you can make use of other trigonometric techniques such as your cosine law. So cosine law. Or let's say your sine law. Let's say that this is now to be your your r. So r squared is equal to a squared plus b squared minus 2ab cosine the angle that is to be here. So let's say that this is to be small letter r, so cosine r. Okay, and as for your sine law, so sine law, so let's say that this is to be angle A, this is now to be your angle B, and this is now to be your angle R. So for your sine law, this is now to be equal to A divided by sine A is equal to R divided by sine R is equal to B divided by sine B. So you can make use of any of these functions. Okay, so take note guys that this is only true if this is to be my nomenclature. Kasi yung iba, ang ginagawa nila, yung mga nasa labas, yun yung mga small letters. So baka malito kasi kayo dun guys. So what I mean here is that in some of the books, ito A yan daw, ito daw C, ito daw B na capital, then ito daw small c, this is to be small b, then this is to be small a. So do not get confused. So for your sine law, so the side, so small c divided by the sum of the angle, so sine c is equal to the side, so that is to be small a divided by sine a, and this to be equal to b divided by sine b. So do not get confused. Basta dapat yung sine, syempre dapat yung angle yan. And this c is to be its opposite side. So dito kasi baliktad yung nomenclature natin. Capital yung nasa side. And yung angle niya is yung small. Kaya naging ganito. So please do not get confused in that part. Okay, so that is to be it. So kunin mo na lang kahit anong method na gusto mo, lahat ng values na gusto mong malaman. Just take note guys that this is just for your resultant, and for your resultant it must be measured from the origin up until here, up until this point. So for example, once again that you are solving for the equilibrant, baliktad naman ngayon. So for the equilibrant, it must be from this point going towards this direction. So, ito dapat yung arrowhead pala, sorry. Pero ba't anong nangyari? Anyway, so ito na dapat yung arrowhead if equilibrant. Okay, so that is for triangle method. Okay, so for this one, so this is now to be your polygon method. So for your polygon method, you can use this if you would be having more than 2. So actually, for any number of vectors. So you can use this for any number of vectors, and this is to be graphical. So by graphical, what you would be doing here is that you would now be drawing. So magdo-drawing kayo ngayon. So drawing kasi ito. So graphical, drawing siya. So just like what we did in the rectangular method a while ago. So dito, graphical yung ginawa natin dito. And dito, graphical na naman. So for example, that you would be having plenty of vectors. So kunwari, meron kang vector dito. Meron kang vector dito. Meron kang vector dito. Meron kang vector dito. And sige, kunwari, 4 lang muna. Okay, so what we will be doing here is that we will now be arranging them from tip to tail. So, yung mga buntot nila, ikakabit natin sa ulo ng kabila. So, in any manner you like, because as long as you are doing it right, kahit anong shape pa yung magawa nyo, your answer must be the same. Okay, so yan. Then, meron na naman dito. Then, ito. Dito. So, ang pangit ng shape na kinalabasan. So, yan, kinonect ko lang sila from tip to tail. So, the next thing that you should do is for you to draw once again a line from this point up until this point. So, sa last, from tip to tail, and measure this line, and get a protractor, then get its angle. So, ayun na yung resultant niya. So, for your resultant, it is now to be equal to the magnitude, whatever magnitude that you have solved for, and followed by the angle or the direction. So, napakasimple nito as long as your drawings are accurate. Pero ang pangit ng drawing ko dito. So, for example na lang na medyo mas maganda naman yung mga vectors. So, for example, that this is to be your vector 1. This is to be your vector 2. And this is now to be your vector 3. So, for you to get the resultant of all of these vectors, so arrange mo sila from tip to tail. So, kunwari ganito. Ganyan. So, arrange ko siya. And they must be scaled, guys. So, they must be scaled. Okay, so after doing that, draw a line here from this point up until this point. So, this is now to be your resultant. And get a protractor or a measuring device. So, you can either get this angle here or this angle here. So, kayo na bahala. And as for its sample problem, tsaka na yan. Okay, so once again, guys, this resultant here is also equal to as if you would be disarranging them. So, for example, ito yung nauna. Kunwari yung nauna, tapos ito yung isa. So, ayan. So, iba na yung arrangement niya, but still, you will be measuring from this point up until the end. And as you can see, this must be exactly the same. So, ito, eksakto siya. So, yan, no? Eksaktong-eksakto. So, whichever the arrangement is, as long as you have drawn them accurately, the resultant should be the same. And once again, if for example, that what is being required in the problem is to be the equilibrant and not the resultant, its arrowhead should be located here. So, nandito dapat baliktad. Okay. So, going back here, so what are to be the advantages and disadvantages of these methods? So, for your algebraic method, this can only be used if your vectors are, so vectors are collinear. And for your parallelogram method, well, you can only make use of this method as well as for your triangle method if there are two coplanar vectors. So for more than that, you cannot use them any longer. So if you have three vectors, you cannot use any of these two any longer. And for your polygon method, so this is to be graphical. So by the way, guys, for your polygon method, this can only be used if your vectors are coplanar. And as for component method, that is to be discussed in the next video.